All right, let's look at your sample quiz for 5-1 to 5-2. Please notice that some of the questions on your quiz will be in a multiple choice format. So number one, we've just got some terminology here. So polynomials with a degree of 1 are linear because they form a line. Degree of 2 is a quadratic. They graph as a parabola. Degree of 3 is a cubic. Degree of 4 is a quartic. Then again, some more terminology. An x-intercept is the same thing as a solution or a root or a zero. So if they ask me to solve the equation or find the zero of the function or find the root, if I graph that, that's going to be the same thing as my x-intercept. All right, then if a is my leading coefficient, so we usually refer to it as ax squared plus bx plus c, when a is less than 0, meaning it's negative for a quadratic equation, then it's going to open down. And if it opens down, then it's going to have a maximum point. All right. If a is greater than 0, so the leading coefficient is positive, then my graph is going to open up. And if it opens up, then that vertex is going to be a minimum. All right, so again, similar here. If A is positive, then it opens up, and if A is negative, then it opens down. All right, so they asked me to sketch the graph of this quadratic. This one is in vertex form, so here's your formula for vertex form up here. So you need to know that if you want to use that on the quiz. And in vertex form, HK, your horizontal shift and your vertical shift, HK is your vertex. So you can see this is x minus h, so it's the opposite of this number, so negative 4. And then plus k, it's not the opposite of this number, it's this number exactly as it is. So negative 4, negative 1 would be my vertex. Because my leading coefficient is a positive 2, I know it's going to open up, and that means that it's going to have a minimum at that vertex. So if we started sketching that, we know that we have the vertex at negative 4, 1, negative 4, negative 1, and that's going to open up. All right, so then it asks me for my axis of symmetry, and the axis of symmetry is if I could fold this parabola on that dotted line right there, it would fold on top of itself. It's symmetric on each side. And you'll notice that every vertical line on the face of the earth has the equation of x equals something. And we can see that x is equal to negative 4 because that's the x value of our vertex. So another way that you could express that is that it's just going to be x equals h, the x value of our vertex. All right, then they wanted to know where our function was increasing and decreasing. So just remember that you're looking at the x values, not the y values, and you always use parentheses and not brackets for these. So if we start off over here, you can see that this piece of the graph was going down, so that was decreasing. So from negative infinity up until negative 4, that was decreasing. All right, then at x equals negative 4, my parabola starts going back up again, and so it's going to be increasing from positive 4. So from positive 4 on to infinity, it would be increasing. All right, here's another one of those. So for this one, it is in ax squared plus bx plus c form. All right, so easiest way to find the vertex for that is to do negative b over 2a. So what we're referring to again is ax squared plus bx plus c. So a would be negative 1, b would be positive 4, c would be negative 3. So if I did negative b, that'd be negative 4 over 2 times a would be negative 1. So I'd get negative 4 over negative 2, which is a positive 2. And then once you know your x value, you can always plug it back in and find your y value. So if I take 2 and I plug that back in, then I'm going to have a negative out in front, and then the 2 gets squared. So the negative was not being squared. If they wanted that negative squared, it would have to be inside parentheses, so that negative was being raised to the second power as well. All right, then 4 times 2 minus 3. So that's going to give us a positive 1. So then my vertex, x is 2, y is 1, my vertex is going to be 2, 1. Because my leading coefficient is negative, I know this is going to open down. So if it opens down, we're going to have a maximum at our vertex. All right, so if we come over here and we just kind of start sketching what we've got, we know that we have a vertex at 2, 1, and it opens down. Our axis of symmetry, again, is going to run right down the center through the vertex. It's a vertical line, so it's going to be x equals, and it's going to be x equals the x value of our vertex, so x is equal to h. All right, then increasing and decreasing, again, these are x values and parentheses, not brackets. And so if I start over here on this portion of the graph, you can see that my function's going up. It's increasing. So from negative infinity to 2, it's increasing. And then at 2, it starts decreasing, and it decreases from 2 to positive infinity. So again, those are x values, right? I'm not looking at the y value of negative infinity. I'm looking at the x value of positive infinity. All right, then what are the x-intercepts? So to find x-intercepts, we set y equal to 0. And so I can say f of x, or y equals 0. So that would be 0 is equal to negative x squared plus 4x minus 3. Now, I don't ever like to factor, because we're going to need to factor this, right? I don't like to factor when my leading coefficient is negative. It just makes it so much harder. And so I'm going to go through and I'm going to multiply both sides of this by a -1, because what I do to one side, I do to the other. That's a legal move. So over here, I'm still going to have 0. And then over here, every one of my signs changed. And now my leading coefficient is positive, so I can factor. So once I factor, I'm going to get x is equal to 3 and x is equal to 1 as my solutions. So those are going to be my x-intercepts. And then my y-intercept is just where x is equal to 0. So again, here's our equation. Let's go through and let's put 0 in for this x, 0 in for this x, and that would give me -3. So my y-intercept would be 0, -3. So if we plot those things, here's my y-intercept, and then here's my x-intercept at 1 and my x-intercept at 3. Also, this y-intercept right here, I could reflect it over across the axis of symmetry. And so that gives me all of my points there. And again, like we said, if you had that point 0, -3, then that just reflects across the axis of symmetry to be 4, -3. All right, then for number 7, for each of those, they had given me the equation and asked me to find the information. This time they give me the information and they ask me to find the equation. So it says create an equation in vertex form. So again, here's that vertex form. Create an equation in vertex form. And it says the vertex is 2, -3. So h is 2, k is -3. So we'll put 2 in for h and we'll put -3 in for k. And then it's going to pass through the point 4, 5. So they told me that so that I would be able to find a right here, because if I can put 4 in for x and 5 in for a, 5 in for y, my only unknown is a. So again, we had the point 4, 5. This is x, this is y. So I'm putting 4 in for x and 5 in for y, and then I can solve for a. So 4 minus 2 is 2. 2 squared is 4. So that's going to be 4 times a minus 3. Add 3 to both sides, and I'll have 4a is equal to 8. Divide by 4, and I'll have a is equal to 2. So I can put my 2 right there, and then that would be my final equation in vertex form. All right, then for number 8, they ask me, a company's profit in producing X t-shirts is represented by this equation. What is the maximum profit possible, and how many t-shirts should the company make to maximize that profit? Okay, so first off, they told me this was the profit equation. So y is going to be the same thing as profit, and then x is going to be the number of t-shirts that I'm making to produce that profit. So if we want to know the maximum, we know that the maximum always occurs at the vertex. So just like we did a moment ago, we're going to do -b over 2a. So b is going to be 8, so -8 over 2 times a is going to be -0.1. So that would give me -8 over -0.2, or 40. So that's my x value. To find y, I need to plug 40 in for x. So that's what we did right here. We took our equation and we just put 40 in the place of each of the x's to get y. Okay, so remember we said that our profit was y, so we just found y was 170. And then we said the number of shirts we were producing was x, and so the number of shirts x would be 40. All right, then for number 9, they asked which of the following could be the graph of x to the 5th and x to the 8th. So remember we said that if it's a power function, that it's just x raised to a power, that if this is an odd number, it's going to have this shape. And if this is an even number, it's going to have this shape. So if this was 5, 7, 9, 25, 55, doesn't make any difference. It's going to look like this. And if this was 8 or 28 or 108, as long as it's even, it's going to look like this. All right, then for 10, it says use the leading coefficient test to tell how the graph of the function is going to start and stop. That's also called its end behavior. And so if the leading coefficient is positive, my graph ends up. If the leading coefficient is negative, my graph ends down. Then I can look at the degree of my polynomial, and if the degree is odd, it's going to start and stop in opposite directions. If the degree is even, it's going to start and stop in the same direction. So for us, our leading coefficient was negative. So when it's negative, that means it's going to end going down or stop going down. And since it was odd, it's going to start and stop in opposite directions. So that means that it's going to start going up. They also asked what's the maximum number of times it can turn, and that's going to be 1 less than its degree. And so this would just be 2. So if I'm looking for something that starts up, turns 2 times, and stops down, that's going to be this guy. Starts up, turns once, turns twice, stops down. All right, then for number 11, sketch the graph of this cubic. So again, remember your leading coefficient tells you how it ends. So our leading coefficient is a positive 1. So if its leading coefficient is positive, it's going to end going up. And if it's negative, it ends going down. Since this degree is odd, it's going to start and stop in opposite directions. If it was even, it would start and stop in the same direction. So we know that it's going to start down and it's going to stop up. And again, the maximum number of times it could turn would be 2 because it's always 1 less than its degree. So we know what the shape is going to be. We know that it's going to start down and it's going to turn once and turn twice and stop up, but I don't know where to draw it. And so that's why they asked me to find the x-intercepts so that I know where to draw this graph. All right, so to find my x-intercepts here, I just need to solve, because remember, x-intercepts are the same thing as solutions or roots or zeros. So I'm going to set my function equal to 0 and find the 0 of the function or the solution. Now this is 4 terms, so to solve when we have 4 terms, we're going to factor by grouping. So I group the first 2 terms together and the last 2 terms together. So I could take an x squared out of my first pair, and I could take a -4 out of my second pair. So because these x minus 3's match, they are a common factor, so I can take out my x minus 3. Put your finger over the x minus 3's and you can see what you have left. X squared minus 4 is my other factor. Now, x squared minus 4 is a difference of squares, so you can write that as x plus 2 times x minus 2, or you can set that x squared minus 4 equal to 0, move the 4 to the other side, take the square root, putting in plus or minus. You'll get the same thing either way. So if I set x minus 3 equal to 0, I'm going to get x equals a positive 3. X plus 2 equals 0 gives me -2, and x minus 2 equals 0 gives me positive 2. Each of these is a single root, so I know my graph is going to go straight through at each of those single roots. Now, you'll notice that this is just a sketch. So yes, your x-intercepts and your turns and your end behaviors should be right, but notice that we're not actually plotting a point to see how high this goes or how low this goes. You don't need to do that in the sketch of your graph.